Hello students, welcome to the lecture on distributed systems, and after the completion we will be able to learn the following objectives. Understand the concept of distributed systems, discuss about the distributed systems architecture, explain the distributed systems and parallel computing, discuss on concept of distributed software and explain the security in distributed systems. Let me first tell you about the distributed systems in brief. Tannenbaum defines a distributed system as a collection of independent computers that appear to the users of the system as a single computer. There are two essential points in this definition. The first is the use of the word independent. This means that architecturally, the machines are capable of operating independently. The second point is that the software enables this set of connected machines to appear as a single computer to the users of the system. This is known as the single system image and is a major goal in designing distributed systems that are easy to maintain and operate. Distributed system. A distributed system is a collection of independent computers that are used jointly to perform a single task or to provide a single service. Examples of distributed system: collection of web servers, World Wide Web, LAN, DNS, XT3 and XT4 series of parallel computers by Cray. These are high-performance machines consisting of collection of computing nodes that are linked by a high-speed, low-latency network. Question: why do we use distributed systems? Answer: there are a number of economic and technical reasons that make distributed systems much more attractive than their centralized counterparts. Let us study each one by one. Cost. Better price performance as long as commodity hardware is used for the component computers. Performance. By using the combined processing and storage capacity of many nodes, performance levels can be reached that are beyond the range of centralized machines. Scalability. Resources such as processing and storage capacity can be increased incrementally. Inherent distribution. Some applications such as email and the web, where users are spread out over the whole world, are naturally distributed. This includes cases where users are geographically dispersed as well as when single resources, example printers, data, need to be shared. Reliability. By having redundant components, the impact of hardware and software faults on users can be reduced. New component network. Networks are needed to connect independent nodes and are subject to performance limitations. Besides these limitations, networks also constitute new potential points of failure. Security. Because a distributed system consists of multiple components, there are more elements that can be comprised and must therefore be secured. This makes it easier to compromise distributed systems. Software complexity. As will become clear throughout this course, distributed software is more complex and harder to develop than conventional software. Hence, it is more expensive to develop and there is a greater chance of introducing errors. Distributed architecture. A key characteristic of our definition of distributed systems is that it includes both a hardware aspect and a software aspect. From a hardware point of view, distributed systems are generally implemented on multi-computers. From a software point of view, they are generally implemented as distributed operating systems or middleware. Multi-computer. A multi-computer consists of separate computing nodes connected to each other over a network. It differs in three ways. Node resources includes the processors, amount of memory, and amount of secondary storage, etc. available on each node. Network connection. A multi-computer with a very high bandwidth network is more suitable for applications that actively share data over the nodes and modify large amounts of that shared data. Homogeneity. A homogeneous multi-computer is one where all the nodes are the same, that is, they are based on the same physical architecture. Example, processor, system bus, memory, etc. Distributed operating system. Distributed operating system (DOS) is an operating system that is built from the ground up to provide distributed services. These services may include distributed shared memory, assignment of tasks to processors, masking of failures, distributed storage, inter-process communication, transparent sharing of resources, distributed resource management, etc. A key property of a distributed operating system is that it strives for a very high level of transparency, ideally providing a single system image. Middleware. The goal of middleware is to create system independent surfaces for distributed applications. The principal aim of middleware, namely raising the level of abstraction for distributed programming, is achieved in three ways. Communication mechanisms that are more convenient and less error prone than basic message passing. Independence from OS, network protocol, programming language, etc. Standard services such as a naming service, transaction service, security service, etc. An important goal of middleware is to hide the heterogeneity of the underlying systems. Distributed systems and parallel computing. Parallel computing systems aim for improved performance by employing multiple processors to execute a single application. They come in two flavors: shared memory systems and distributed memory systems. Distributed systems in context. The study of distributed systems is closely related to two other fields: networking and operating systems. The relationship to networking should be pretty obvious. Distributed systems rely on networks to connect the individual computers together. Operating systems are responsible for managing the resources of a computer system and providing access to those resources in an application-independent way and dealing with the issues such as synchronization, security, etc. that arise. The study of distributed systems can be seen as trying to provide the same sort of generalized access to distributed resources and likewise dealing with the issues that arise. Many distributed applications solve the problems related to the distribution in application-specific ways. Basic problems and challenges. Transparency. Transparency is the concealment from the user and the application programmer of the separation of the components of a distributed system, that is, a single image view. Scalability. A system is scalable if it can handle the addition of users and resources without suffering a noticeable loss of performance or increase in administrative complexity. Dependability. Dependability requires consistency, security, and fault tolerance. Performance. Transparency, security, dependability, and scalability can easily be detrimental to performance. Flexibility. A flexible distributed system can be configured to provide exactly the services that a user or programmer needs. Common mistakes. Developers with no experience typically make a number of false assumptions when first developing distributed applications, which are: the network is reliable, the network is secure, everything is homogeneous, the topology does not change, latency is zero, bandwidth is infinite, transport cost is zero. There is one administrator. Principles. Some key principles of distributed systems are: system architecture, communication, synchronization, replication and consistency, fault tolerance, security, naming, paradigms. Most middleware systems are based on particular paradigms or model for describing communication and distribution, like shared memory, distributed objects, distributed file system, shared documents, distributed coordination, agents. Rules of thumb. We present some rules of thumb that are relevant to the study and design of distributed systems. Trade-offs. At a certain point, trade-offs must be made. A choice must be made about which requirement or property is more important and how far to go when fulfilling that requirement. Separation of concerns. When tackling a large complex problem, such as designing a distributed system, it is useful to split the problem up into separate concerns and address each concern individually. End-to-end argument. Implementing encryption as part of the communication layer, for example, may be less secure than end-to-end encryption implemented by the application and therefore offer users a false sense of security. Policy versus mechanism. Separation of policy and mechanism helps to build flexible and extensible systems and is therefore important to follow when designing distributed systems. Keep it simple, stupid, KISS. If possible, solutions to problems and resulting architectures should be simple rather than mind-numbingly complex. Distributed software. In designing distributed software, we often touch upon the same set of goals and problems. These general goals are transparency and scalability. Transparency refers to hiding the fact that we may have many machines involved, and scalability refers to creating software systems that can scale well as we add more machines because the number of users, data or computations involved goes from small to huge. The most common distributed systems today are those with loosely coupled software and loosely coupled hardware. The quintessential example is that of a workstation on a LAN. To accomplish a true distributed system, we need certain capabilities: a single global IPC mechanism, a global protection scheme, uniform naming from anywhere, same system call interface everywhere. Next question that arises is, why build them? Price-performance ratio. With multiple CPUs, we can get almost double the performance for double the money. Distributing machines may make sense. It makes sense to put the CPUs for ATM cash machines at the source, each networked with the bank. Cooperative and social networking. Users that are geographically separated can now work and play together. Increased reliability. A company may buy a computer. Eventually, the workload is too great for the machine. The only option is to replace the computer with a faster one. Networking allows us to add on to an existing infrastructure. Remote services. Users may need to access information held by others at their systems. Mobility. Users move around with their laptop computers and smartphones. Design challenges. There are a number of issues with which a designer of a distributed system has to contend, like transparency. Transparency means hiding distribution from the user's programs. Flexibility. It should be easy to develop distributed systems. Reliability. Reliability encompasses a few factors. Data must not get lost, the system must be secure, and the system must be fault tolerant. Performance. We have to understand the environment in which the system may operate. Scalability. We would like a distributed system to scale indefinitely. Service models. A centralized model is one in which there is no networking. All aspects of the application are hosted on one machine that users directly connect to that machine. Client-server model. The client-server model is a popular network model consisting of three components. A service is the task that a particular machine can perform. A server is the machine that performs the task. The client is a machine that is requesting the service. Peer-to-peer model. A peer-to-peer model assumes that each machine has somewhat equivalent capabilities, that no machine is dedicated to serving others. An example of this is a collection of PCs in a small office or home. Thick and thin clients. There are two schools of design identified as thin client and thick client. A thin client is designed around the premise that the amount of client software should be small and the bulk of processing takes place on the servers. The opposite of a thin client is a thick client or fat client. In this configuration, the client performs the bulk of data processing operations. Multi-tier architectures. The traditional client-server architecture is two-tier architecture. The user interface generally runs on a user's desktop and application services are provided by a server, for example, a database. In this architecture, performance often suffers with large user communities. These problems led to a popular design known as three-tier architecture. Here, a middle tier is added between the client providing the user interface and the application server. The middle tier can perform queuing and scheduling of user requests. It may also employ a transaction processor TP monitor to queue messages and schedule back-end database transactions. And processor pool mode. One issue that has not been addressed thus far is that of idle workstations or computing resources. One option is to simply ignore them. It is no longer a sin to let computers sit idle. Another option is to use all available computing resources for running jobs. Security in distributed systems. Distribution not only introduces additional risks to computer systems, but also adds complications to dealing with the risks. For example, communication may introduce significant time lag into the system in respect of security-related information. This may make it difficult for the security management system to correlate information which, taken together, would indicate a security breach. Splitting the system into different geographical, political, technical, or administrative domains complicates the setting and management of a coherent security policy. It also adds to the difficulty of tracing security breaches which are initiated from a different domain. Security benefits of distributed systems. Unauthorized access to corporate data can provide the intruder with valuable strategic information. The advantage of distribution in this case is that it allows sensitive data to be distributed throughout the system. Distribution can provide alternative locations from which to acquire processing resources. One advantage of distribution is that it does not constrain all components of a system to accept the same security regime. Security objectives. Some of the security objectives of distributed systems are as follows. Confidentiality. This typically means the prevention of unauthorized access to stored data files and the prevention of eavesdropping on messages in transmission. Integrity. This prevents loss or modification of the information due, for example, to unauthorized access, component failures, or communication errors. Availability. Maintaining the availability of information held within systems or communicated between systems, ensuring that the services which provide access to data are available and that data is not lost. Authentication. Authenticating the identity of the originator of a message gives confidence in electronic mail systems that messages are genuine. Authentication of message contents enables the detection of integrity failures in messages. Non-repudiation. This is the prevention of a user wrongly denying having sent or having received a message. Access control. Providing access control to services or their components to ensure that users can only access services and perform data accesses for which they are authorized. Access control is one means which is used to achieve integrity and availability. It can be provided by physical and/or logical mechanisms. Unauthorized access to a personal computer may be prevented by a key lock disabling 5 on the keyboard. Audit trail. Providing an audit trail of activities in the system to enable user accountability. An audit trail provides evidence of who did what and when. Security alarm. The objective in this situation is to minimize simultaneously the risk of loss if there really is a security failure and the inconvenience to the user if there is a false alarm. Summary. Now in the end, let us summarize what we have learned in this lecture. The alternative to using a distributed system is to have a huge centralized system such as a mainframe. A key characteristic of our definition of distributed systems is that it includes both a hardware aspect, independent computers, and a software aspect, performing a task and providing a service. A key property of a distributed operating system is that it strives for a very high level of transparency, ideally providing a single system image. The study of distributed systems is closely related to two other fields, networking and operating systems.